Good morning or good afternoon. I'd like to welcome everyone to Cisco Support Community Expert Series Webcast. We're glad to have you with us. A few housekeeping notes to begin. As you entered the WebEx console, you either joined us by audio broadcast or by phone, which was automatically muted. Because of our large audience in attendance today, you will remain muted throughout the event. When you have a question, please feel free to enter it into the WebEx Q&A panel as you think of them. You can find the Q&A panel in the bottom right-hand corner of the console. Please leave the WebEx chat window for communication to our WebEx facilitator for any problems or issues you may be experiencing today. We would appreciate your input regarding today's webcast. A short survey will appear when you close your browser at the end of the event. At this time, I'd like to pass it over to our host for today, Dan Gerson. Dan?
Thank you, and welcome to the Cisco Support Community. Today we present a live Cisco Support Community Expert Series webcast. Our topic today, Simplifying Enterprise QoS with Media Awareness. My name is Dan Gerson, and I will be moderating today's event. Our expert joining me today is Eric Yu. Eric is a customer support engineer at Cisco, responsible for supporting video performance on Cisco borderless network solutions. He has 10 years of experience in the telecommunications industry, designing data and voice networks. Previous to his current role, he worked as a network consulting engineer for Cisco Advanced Services, responsible for designing and implementing Cisco Unified Communications for Fortune 500 companies. Eric holds CCIE certification 14590 on routing and switching. Welcome, Eric.
Thank you, Dan.
Our expert panelist today is a distinguished support engineer, Michael O'Brien. He will help in answering some of your technical questions during today's event. Now, I'd like to briefly outline the format for today's expert series event. Eric will start with a presentation on simplifying enterprise QoS with media awareness for the first hour of the program, and then we will provide an answer to the question, what do Cisco Medianet, New York Yankees, and the Dallas Cowboys all have in common? So stay tuned for that. Then we'll dive into the live question submission from the audience for the remainder of the event. During our live presentation, you may submit your technical questions to be answered by our presenter and the expert panelist using the Q&A box on the right side of your console. The team of technical experts is well-versed in Cisco Medianet and video QoS, so please do begin posting your questions now to give us the best chance of answering them. If you experience any technical issues, please post those questions in the chat. We'll be asking polling questions during today's webcast, so we do encourage you to participate by answering them. Also, you may download a copy of today's PDF presentation using the link in the chat window. Now, let's get started with today's event. We'll kick things off with a polling question. What is your role with supporting the network for voice and video? Is it A, system engineering, B, network operations, C, voice and video engineering, or D, end user voice or video? Please take a moment to answer so Eric can tailor his presentation to your needs. Okay, now I'd like to hand the mic over to our expert, Eric Yu, who will give you advice on Cisco simplifying enterprise QoS with media awareness. Eric?
Thank you, Dan. Again, good morning, good afternoon, and good evening. I'm going to jump right into this. So a while back, Cisco IT was deploying a new UC feature, and some of the early end users were reporting intermittent voice and video call quality problems. And without some of these tools and utilities and methods that I will be sharing with you today, it took us approximately 2 weeks to resolve the root cause, and the bulk of that time went into investigating or finding out, correlating the symptoms back with what the users were reporting. So today's agenda, I will be covering our discussion with 3 primary topics. First, I'm going to go over the Cisco Medianet overview. I'm going to just pretty much answer the general question, what is Medianet? And then moving specifically into Medianet media awareness, and then talking about how media awareness can integrate with some of the existing QoS strategies or some of the existing iOS feature sets to simplify how we actually manage our networks for voice and video. Okay. So what I'm showing you here is our logical reference topology. And the reason I want to show this to you is that Cisco Medianet is an end-to-end architecture. It impacts the endpoints, the access layers, distribution layers, and the core layers of the network. And in Cisco Medianet, we will be referring back to this topology. I will be showing you configurations from this topology and some of the working show outputs as a result from this network topology. Okay. We purposely built this slide deck to include a lot more information than I probably have enough time to go into a lot of details. So I've included reference slides, salt and peppered all over this presentation, just as a point of reference. And on this slide, I'm showing you the logical reference topology, and I've overlaid the hardware platforms that currently support some of the Medianet features. So I've also included the reference URL at the bottom of the slide here. So please reference the data sheet for more of a comprehensive list on what's actually being supported. That's what's actually supporting Medianet today. Okay. And from the purpose of building out our working configurations, these are some of the required software and licensing features that we had to turn on for Medianet video monitoring. I have a separate slide that will actually show what the software and licensing requirements are to support media awareness. But for the time being, I want to introduce Medianet video monitoring features and the software licensing. All right, so Cisco Medianet. What is it? Taking the layered approach, Cisco Medianet, I mentioned earlier, is an end-to-end architecture. But essentially what that boils down to is that it's a set of features that we can run on a converged multi-service IP network to help network operators and administrators support video a lot easier than with the existing tools that are available. Right? So taking the layered approach, starting from the bottom up, auto smart ports, this is the idea of self-configuring or self-provisioning switch ports, where the switch port is smart enough to know what kind of endpoint you are, and then configuring the switch port automatically. And moving up the stack, Mediatrace and video monitoring. These two specific features fall into the Medianet video monitoring feature set. And essentially what these two capabilities provides us is it provides us the ability to see in real time what actual performance is like for my video session. Okay, so I have working examples for Mediatrace and video monitoring. And then finally, the bulk of our discussion today, I will be covering metadata, or rather flow metadata. And this is essentially the media awareness component of the Cisco Medianet solution. And finally, at the very top, traffic simulation. For those of us who are familiar with IPSLA, that has been around for a while. But recently with Medianet, IPSLA video operations has been enhanced to allow administrators to model a specific, to model live video, to model a live video session, and then replay that back onto the network to see how that will actually impact the network. And again, unfortunately, because of time constraints, I will not be going into any details about IPSLA VO. And I just wanted to share this slide with everyone, just to give everyone an idea what is Medianet. Okay. All right, so I want to start off by introducing the problem. All right, preserving quality of experience. On one end, I have a telepresence endpoint. I'm dropping packets in the network pre-tagged with CS4, right? And on the other end, when the packet comes out, it's being re-tagged somewhere. Immediately, in this type of scenario, a few questions gets raised by several support organizations within IT. Right? First question is, are all users getting impacted? And the second question moves to, all right, who is retagging these packets, right? And how do I prevent this from happening again? But ultimately, we're trying to figure out who owns this problem. Right? And if your enterprise has deployed a comprehensive global QoS policy, it is up to probably the network operations engineers to pretty much go and figure out which device along the network, in the network, is retagging those packets. Right here, I'm essentially just sharing the industry standard that's actually used for a guideline on how applications should be mapped to DSCP values, right? And to implement this and to support this from a configuration perspective, the Cisco policy language has been around for a while now, right? We're using traffic classes to identify what we want to apply our QoS policy against, and then we're using policy maps to build a policy, and then finally we're applying this policy map against an interface for incoming or outbound traffic, right? But the idea is we want to enforce our end-to-end global QoS policy, right? And for the most part, this is the method that's currently available to support that goal, right? But coming back to the problem of isolating the problem in the network, right? In a multi-hop network environment, such as Cisco's IT, we didn't even know where to begin troubleshooting, right? So at the time, without Mediatrace, we had to telnet or SSH into every single network device along the way, kick off my favorite show commands, save the output to my text file on my desktop somewhere, rinse and repeat the cycle, and hoping that I log into all the right routers, collect the data. Once I have the data, I go back and then I would actually go through the analysis, right? So at the time, without this utility, without Mediatrace, I didn't have the ability to dynamically ask the network to tell me what performance is like from a hop-by-hop basis, right? Here, I'm showing you several things here, right? The Pervasive Mediatrace responder. Just to introduce Mediatrace really quickly, make sure everyone's on the same page, we all know what traceroute is, right? We send a traceroute request into the network, and on my console where I kicked off the traceroute, I actually get a reply from every single device along the route hop telling me which device had forwarded my traceroute message, right? But with Mediatrace, it gives me the same capability, but it actually gives me more data when the results are actually printed on my console, right? With Mediatrace, I now get hop-by-hop information in addition to performance metrics as it pertains to the flow that I want to monitor. Okay, so I have a working example, a configuration to show output actually illustrate exactly what I'm trying to say. But here, I turned on Mediatrace responder all over the network, and the reason I had to do this is because Mediatrace is a feature within iOS. Unlike traceroute, where it gets turned on automatically when you configure an IP address on a host, I have to explicitly define the network device as a Mediatrace responder. Okay, and from the terminal where I want to kick off a Mediatrace, I have to instruct it that it will be the Mediatrace initiator. And here in my example, my access switch at my branch site, I've configured it as a Mediatrace initiator to source the signaling message using the IP address from the loopback interface. Okay. And notice how I turn Mediatrace responder all over the network. And the idea is I'm casting a wider net to be able to catch any potential problems in the event I want to be able to pull the network for performance. All right, so here, it doesn't matter what path my media session, my media flow is taking. If I can ask the network and all the devices along the media path what its performance is like as it pertains to a specific flow, I will get a single console that actually prints the results for each hop. Okay. So, how do I actually kick off this trace? Well, I'm sitting at the console on my 3750 at the branch site. I type in commands Mediatrace pull path, source IP address of my source telepresence endpoint, destination IP address of the remote site telepresence endpoint. And then at the very end here, I'm specifying the type of report that Mediatrace should be asking from the network. So here I'm specifying that I'm asking the network to provide me a performance monitoring report. I hit enter after this keyword, and the process makes me wait. Right? This is similar to traceroute, right? Well, I'm actually waiting for the trace to complete and to get a final printout back onto my console. So as I'm waiting, what's actually happening? what's happening is, as soon as I had hit enter, I'm sending an RSVP TP message out into the network. All right, so I want to get this point straight. RSVP is a transport mechanism, and it does not have any, in this use case, it does not have any relations to call and mission control. Okay, so when I first learned about this, I confused RSVP with CAC, right? But essentially, call mission control is an application that uses the RSVP message exchange mechanism, and Mediatrace is a completely separate application that it also uses RSVP message exchange mechanism. Okay, so with that being said, I don't have to go into every router and on its active interface configure IP RSVP bandwidth. Okay, so that's not required. All I need to do is pretty much configure the router for a Mediatrace responder, and the device is actually smart enough to understand these RSVP transport mechanism messages for Mediatrace. Okay, so when Mediatrace is kicked off from the initiator, the RSVP message inherently will take the same path as the media packets, right? So it'll follow the media path as my actual telepresence flow, and at every hop that understands this Mediatrace request, it will actually query itself for performance and then send the results of that performance query back to the initiator. Okay? So what do I get on my console? On my Catalyst 3750 switch, I get a console printout. Here I had to concatenate it just to fit everything on the screen. But here I'm showing the results of a Mediatrace session. I'm getting hop by hop information. I'm getting the host name from hop 1, hop 2, hop 3. It's telling me the inbound and outbound interface that's responsible for routing my telepresence packets, right, at every single hop. And here I'm highlighting the fact that the router is reporting the DSCP value as it sees the packets being sent through its interface or being routed through the network device. So here, just for sake of demonstration purposes, at hop 2, or rather my cloud here, I had retagged my telepresence packets to DSCP00, right? So from a troubleshooting perspective, if I want to ensure end-to-end QoS and ensuring that my DSCP values are being preserved end-to-end, Mediatrace can quickly tell me if any device along the media path is actually where packets are being retagged, right? So here at hop 2, I can immediately tell something went wrong at hop 2. Perhaps I should start focusing my troubleshooting efforts at this device. Okay. And here on hop 1, the second section where I highlighted, where I've encircled everything in red, because I instructed Mediatrace to query the network for a performance monitoring report, it actually came back with RTP type metrics for my telepresence session, right? So very quickly, from a high-level perspective, the router is telling me at this point in time when it was doing a Mediatrace response, it had detected jitter average values for my specific telepresence session as this value here, right? And of course, I get a readout from across the board. And with this utility, I can now actually quickly isolate a problem and quickly be able to determine if my end-to-end QoS is being broken somewhere. Right? The question we get asked often is, can I get this same Mediatrace output in a GUI type format? And the answer to that, as shown here on this slide, is yes. Here, I'm showing you a Mediatrace GUI output from our Cisco Prime Collaboration Manager. And the idea is not all engineers or technicians have CLI access to network devices, but we would like some of those support engineers to be able to use this feature. Unfortunately, with Cisco Prime Collaboration Manager, this is an NMS that specifically supports the telepresence solution, meaning it has hooks into Call Manager. It knows when a telepresence call is active. It has the ability to detect and discover network devices that are MediaNet aware or capable, rather. So in our example here, the Cisco Prime Collaboration Manager has sent a Mediatrace request to the initiator to kick off a Mediatrace. When the results came back to the initiator provided that data in XML format back to Cisco Prime Collaboration Manager, and Cisco Prime Collaboration Manager has actually painted this hop-by-hop picture for us. All right? And if I mouse over to, unfortunately this is a PowerPoint slide, but if I had mouse over one of these devices, I would have gotten a little bit more statistical readout on what performance is like. So I just talked about Mediatrace and being able to use that feature to isolate fault in the network, right? And specifically fault being if some device along the way has retagged my DSCP values, like I now have an ability to quickly identify where that is. But what if I want to scrutinize my actual telepresence session, right? I want to look at the granular level what performance is like on a per flow basis for my telepresence stream. Right, so with Cisco Medianet's performance monitor actually gives me that ability. So Cisco Performance Monitor leverages flexible NetFlow, and just very quickly, it gives me the idea to discover the traffic flow, and it uses the same configuration methodology as flexible NetFlow, where I can actually define what is it of the IP flow that I care about for matching, and what are the specific metrics that I want to calculate against that particular flow. Right? I build this configuration using Cisco policy language, and essentially I can get granular, or I can actually use the default setting to actually query what RTP performance metrics is like, and also what TCP performance metrics is like. Right? And the idea is I can actually look into performance at every single hop. Right? So the next slide here, I actually have an example output and a sample configuration on how I had this set up. So in my lab, I opened a YouTube session, right? Essentially a TCP session out to the internet, right? And I built a QoS policy that essentially says, hey, I want to measure performance for web traffic, and I want to know about the TCP, the transport round trip timers, okay? And from the output here, when I have a live session, I type show performance monitor status on my Cisco IIS router. I essentially get this printout, okay? And the router reports to me in real time what it sees for the round trip time for my TCP session, what its IPDCP values are, and other tidbits of metrics that I may be interested in, okay? So the reason I'm here, I just caught this down. The reason why I'm seeing not applicable or NA here is because I didn't give the router enough time to actually crunch the numbers and to print out a specific metric. Okay, so here this was a screenshot, a user error on my part, where I should have captured something to show us the round trip timer values for my YouTube TCP session. So apologies for that. So with Performance Monitor, it's great if I have CLI access, and I can actually peer into performance to see what a flow is performing on that network hop, right? But what if I want to be able to trend this data or build some sort of baseline over a period of time? So because Performance Monitor leverages the flexible NetFlow configuration, Performance Monitor 2 has the ability to export the performance statistics that I just showed you in the previous slide. It has the ability to export that data as a NetFlow record to a NetFlow collector somewhere. Okay. So here, I'm showing you a screenshot from our lab's scrutinizer. I'm essentially sending NetFlow records out to this NetFlow collector, and the NetFlow collector sits there and listens for these data updates to occur, right? And it stores enough of this where, depending on the tool I'm using, I have the ability to actually pull interesting reports. Right here, again, I'm only showing a quick snapshot of what Performance Monitor can do when integrated with a NetFlow collector, right? So one of the things I want to point out here is this is a NetFlow collector collecting performance values for a live telepresence call, right? Now I'm seeing percentage of packet loss, I'm seeing jitter information. Whereas in the past, I would not have been able to get these type of metrics if Performance Monitor was not available. Okay. So So this brings us up to a second polling question, and very quickly, just want to get feedback from the audience. I'm curious to know if your organization actually have a global QoS policy, right? And previously, I think the results from the previous poll, it looks like there's actually a majority of us who are actually engineers that support video on our networks. So again, out of this from the member audience, I'm just curious to know if you guys actually have a global QoS policy deployed, or if not, maybe perhaps you have something something that you have work in progress. So as the results come in for that, I'm going to move on in the interest of time, and I want to start talking to you about Medianet's media awareness features. And I know I've highlighted NBAR here, but I actually have a story that will lead up to why NBAR will actually work pretty well in a specific type of scenario. So HTTP is now the new TCP. And that's the message I want to send with the slide. And if I deconstruct that message, what does it mean? What it means is that applications now doesn't matter what, for the most part, doesn't matter what it is, for specific cloud solutions, they're sending data through port 80 or port 443, right? These two ports are always open. And if I want to build a QoS policy against these type of applications, I now run into a problem where I can't differentiate, WebEx traffic from, say, for example, Salesforce.com traffic, right? And if, especially if each type of these traffic is traversing port 80 or port 443. So I can use a Five-Tuple. I can use an event ACL to match based on Five-Tuple information, but from a configuration perspective, that doesn't really scale well, right? And if there's encryption, right, for the web session, I can't, due to the nature of encryption, I can't tell what this specific traffic flow is. How do I classify that, right? And then finally, from the user session experience perspective, right? Everyone's probably logged on to WebEx now, but using this WebEx experience, you probably have a TCP session up to connect to the WebEx servers. You may be using voice over IP, and if there's video involved, there may be possibly video involved in this same WebEx session. But the point is, within the single application, I may have multiple flows. And from a network administrator or network engineer perspective, how do I enforce a QoS policy for this type of application, right? And then finally, as enterprises move from IPv4 to IPv6, I don't want to recreate a QoS policy for my new IPv6 type applications, right? I want to be able to use what I have, and just because my QoS policy is just hammering something out, it took a lot of time. I don't want to duplicate that effort, right? So it looks like the poll results are in, and it looks like there's the majority of us don't really know if there's a QoS involved, a QoS policy deployed, but it looks like the second majority is that the organizations actually do have QoS, like a global enterprise QoS deployed. Great. So hopefully from this slide, I just want to raise a little bit of awareness with, as the applications and trends change on the internet, with internet applications, it just makes it a little bit harder for us to actually enforce our existing QoS policy, okay? So one of the answers that I can use, or one of the solutions I can use to resolve that problem of identifying the different traffic flows, in order for me to apply my QoS policy, I can use NBAR. NBAR has been around for a while now, right? NBAR has the ability to do deep packet inspection, meaning it can look into the payload of a packet to determine what type of application it is that this packet is actually transporting, right? NBAR 2 was recently introduced. I forget the exact timeline, but with NBAR 2, it's now been advanced to support over 1,000 applications, meaning NBAR can now actually recognize over 1,000 applications and its protocols, TCP and UDP ports, right? And with NBAR, I have to statically configure this at each and every network device hop, just so that NBAR can actually learn what a flow is, and then be able to use what it learned with a different type of reporting mechanism. Okay, so just to introduce what I thought was actually pretty cool that was released with NBAR 2. With the NBAR 2, now actually they categorized how the application attributes are set up. Meaning, I can build a traffic class, or my class maps, based on application attributes. Right? And depending on how granular I want to get, I can actually say, hey, I want to apply some sort of policy against all telepresence traffic, right? And from a configuration perspective, I don't have to go out and build ACLs that match all my telepresence, endpoints and their subnets information. I can essentially say, hey, match based on telepresence media type flows only, and apply a policy against it, right? So with NBAR 2, and also with media awareness flow metadata, it now gives me the ability where I can use class maps to match based on application attributes. Okay, here I'm just providing this as a point of reference of what the currently available attributes are that's available for matching, right? From NBAR and media awareness perspective. I touched on this just in the previous slide. With NBAR 2 and with media awareness, I can now say I want to enable performance monitoring for telepresence flows only, right? So video, like in the past, when I was learning this, what is RTP packets? So RTP packets is voice and video. Well, voice and video, that was like a generic statement. But how do I differentiate that this is RTP video for WebEx versus RTP video for Skype, right? There wasn't really a way for me to do that, right? But again, coming back to using NBAR, I can now actually say, hey, I want to match, I want to build a policy against telepresence video packets only, and I don't really care about my Skype traffic, right? And now with NBAR 2, I actually now have this ability to do this, okay? All right, so let's look at a working configuration. What can I leverage from NBAR 2? So here I'm showing you NBAR and NBAR being integrated with flexible NetFlow. Okay. On my WAN edge router here, I've configured NBAR to discover the protocols that's being routed in and out of gigabit 00. And then I've defined a flow monitoring policy that says, hey, I want to match from the IP flows that are coming in and out of this interface. I want to match the Five-Tuple information. In addition, I want you to be able to associate some sort of attribute against this Five-Tuple flow, right? And then I apply this on my gigabit 00 interface, and as traffic gets routed through gig 00, I type the show flow monitor NBAR flow cache command output. It prints out the Five-Tuple information for my telepresence flow. It tells me the source destination address, source port, destination port, the IP DSCP value, because I asked Flow Monitor to report this information for me. And it's also associating the application name for this particular flow. So from a support perspective, if someone's reporting to me, hey, I'm having problems with this telepresence endpoint and I only know the IP address, without sifting through lines and lines of code, when I kick off my first show command, I can essentially now just say, hey, all right, this IP address matches what the user's telling me. And, oh, hey, look, it seems to be a problem with telepresence media or maybe telepresence control, all right? And the idea here is, the idea from the slide here, the main message is, I want to emphasize that NBAR can actually make it easy for the administrator to digest all this data that gets printed out at them, right? All right, so the next feature I want to talk to you about is metadata flow. And metadata flow, this was recently announced. This was recently released, I believe, at Cisco Live San Diego. And what this is it takes NBAR to the next level. I don't want to say it's NBAR because it's completely separate from NBAR, but recall that NBAR is static, right? You had to turn on NBAR at every single hop along your network. But what if there was a way where, attributes gets announced into the network, and attributes that gets announced are actually learned and stored in the database along every network device hop, and then as these packets arrive at these network devices, services can actually be applied to those specific type of attributes. Right? So coming back to this specific slide here, metadata attribute flow. What I'm showing you here is I have a WebEx laptop, a WebEx endpoint essentially. I have a connection going out to the internet cloud somewhere. And the thing I want to accomplish here is I want to apply TOS for my WebEx session. And coming back to the original problem, I can use NBAR at every single hop, right? I can turn it on here, 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 and it's pretty much at every single hop. I'm too lazy. I don't want to do that. I want to be able to just have the network learn what type of traffic this is, and then build a policy against what it has already learned. So with the WebEx client, depending on the type of version I'm using, the WebEx client announces metadata attributes into the network prior to sending out the actual WebEx session. Okay. So here in my example, the WebEx client is doing a shout out. Right? Hey, I'm a desktop conferencing application. I'm specifically a WebEx client, and here's my associating Five-Tuple flow identifiers. Right? And as this information gets propagated through the network, a database gets built to store this data. Okay? And just to build out flow metadata and its relating components really quickly, metadata consists of a few actors, a few roles. There's producers, there's consumers, and then there's obviously the database that I just talked about. And then there's a signaling message that allows the attributes to be propagated across into the network. Okay? So here, I'm not going to go into too much detail, but I just listed what are some of the examples of a metadata producer and what are examples of a metadata consumer. Okay? I'm going to have examples and show output that will actually show you what I mean when I talk about metadata producer and also consumers. Okay? All right. So as I mentioned earlier at the top of the hour, this is a reference slide that I used to actually share with you what I actually built out in my lab to build this output. Right? In my lab, I'm running a WebEx client, running version WBS 28, and it's running the MSI API that gets installed with WebEx. And I want to have a little more details on what actually MSI is, okay, in the upcoming sections. I have a Catalyst 4000 switch. I'm running 15.1.1 SG, and then of course, I'm using the flow metadata features where the flow metadata table is available to learn what these attributes are. And then I'm also using on my ISR G2 15.2.1T just so that my ISR router can understand these metadata attributes. But again, please reference the data sheet for more of a comprehensive list on what's actually being supported from media awareness. Okay. So, and of course, I also have another slide that shows some of the results for a Jabber client that I'm running. That Jabber, specifically Jabber client UC running 9.0, and I'm running the MSI API. Okay. All right. So I talked about metadata and the multiple roles that's involved, or multiple components that's involved. So I'm going to go over what a flow metadata producer is. All right, so flow metadata producer, if you just think back to the previous slide where I showed you a little icon where the icon is doing a shout out to the network. Hey, I'm a desktop conferencing app, and I'm running this specific Cisco WebEx software version. That's essentially what a producer is, right? It announces attributes into the network for consumption. And specifically, what does that mean? It means that Cisco Media Services interface was installed with my WebEx client that announced the WebEx attributes into the network prior to the WebEx session being set up. Okay, so what is it? MSI, or Media Services Interface. It's an API. Okay, application programming interface. Essentially, it's an API that allows middleware. It's a middleware that allows applications and endpoints to leverage some of the existing network services that we know and love. Right? So, for example, next slide here, I'm showing you another output from the perspective of my access switch. MSI was installed with a laptop running Jabber. I type show CDP neighbors at the console, and notice how CDP has detected that this is a Windows machine running MSI that's attached to port F06, right? So keep in mind, CDP, it has always been a Cisco proprietary protocol, and is used to detect the type of endpoint that's hanging off on the other side of a Cisco device, right? So if, in the past, because it was a Windows machine, we wouldn't have known that this was a Windows machine. But because of MSI and because of its middleware capabilities, CDP can now actually be leveraged by the application, right? And at some point, I don't know the timeline for this, but maybe Mike can help me look this up. There are talks about opening up MSI to the developers community to essentially allow application developers to leverage some of these network resources, some of these network services that I just talked about. Okay, so for the next upcoming sections, the specific service I want to focus on, I want to talk to you about flow metadata. Okay. And the past two slides, I just wanted to show you that MSI is a producer of metadata, and I want to introduce the concept of what MSI actually is. Okay. So what happens if I have an endpoint that does not support MSI or doesn't allow MSI to be enabled, right? So how do I leverage the flow metadata features of Medianet? Well, media services proxy, I can actually enable this feature to run on my access layer switch. And what this does is that depending on the type of application that's attached to this switch, and here I'm using SIP as an example. When a SIP invite gets sent to the network, the SDP portion of the message contains specific attributes. What MSP can do is it can parse those attributes, take the labels from the attributes, and then re-originate flow metadata signaling message into the network. Okay. So to answer the question, how do I leverage flow metadata services if I have endpoints that cannot support MSI? The quick and dirty answer is you have the option of using the Cisco Media Services proxy. And again, I've included the software version that I used in my lab to actually generate to build out this presentation. Okay. So I talked about sending messages or signaling message in the network for flow metadata. So what is it? All right. I'm showing you a Wireshark packet capture, and essentially, prior to setting up my WebEx, establishing a WebEx call, I'm sniffing. I have a span port that's sniffing packets for all sessions coming in and out of my WebEx host endpoint. But essentially, what metadata signaling is, again, it's an RSVP message, right? But to be specific, it's an RSVP path message. And again, please keep in mind that RSVP here in this context is being used as a transport only, and there is no call and mission control involved. Okay. If I drill down further into the message body of the RSVP path message, I can actually find a metadata AppID embedded in the message, right? So this application identifier, this was originated from the WebEx client with MSI, and as the RSVP message gets propagated through the network devices build a database to store this information, right? And once I have this information stored somewhere, I can later actually reference these data points in the different types of applications, right? So in the next section, I will actually have working configurations and show outputs that illustrates what I'm talking about. I want to show you how QoS can use metadata signaling, and how it can actually be leveraged to simplify what your QoS policy can look like. All right, so how do I configure this? At the global configuration level or at the interface level. All I need to do to enable the network to be aware of these metadata signaling messages is essentially the command metadata flow. Okay. Again, here I'm illustrating that the RSVP transport path message is following the same path as my actual WebEx session. Okay. And again, the idea is I only care about applying services for my WebEx session at the device hops that's actually routing my packets, right? So again, that's why RSVP was selected to transport this specific application. Okay. So what does the contents of my metadata flow database look like? So here on my ISRG2 router, that's actually been configured for metadata flow. At the console, I'm essentially typing show metadata flow local flow ID command, and the database entry is telling me the Five-Tuple information of the flow. Notice how it's telling me that this is an encrypted WebEx session, right, 4443. But this encrypted session, without actually looking into the payload because of encryption, I can tell that this is a WebEx session, right? Just solely based on the fact that the WebEx client itself announced these attributes into the network, right? So, very quickly, if I have this database that's built for WebEx, this means that I now have the ability to use class maps to match based on these specific attributes. Right? So in the past, whereas I'm just in the past, where I'm only restricted to matching based on on DSCP values or ACLs, I can actually now just build class maps to match based on metadata attributes. So guys, I know I'm giving you a lot of information, so please submit your questions to the panelists, and hopefully, if there's any question that comes up, I want to make sure we get any confusions or questions answered, okay? All right. So one thing to keep in mind when we want to deploy metadata flow in a network, because flow metadata uses RSVP as a signaling transport mechanism, we have to permit IP protocol 46. Okay. So here, if for example I'm denying IP protocol 46, metadata will only work up to that point where it was actually denied. So every other downstream device that does not see the flow metadata signaling message, the flow metadata table database, it will not get populated with the relevant information. Okay. So again, I just want to share that here. If there's like firewall or any filtering rules in place on the network somewhere, just be sure to enable protocol IP 46. Okay. All right. So far, I've covered what Cisco Medianet is from a high-level overview, and I've introduced. I talked about Mediatrace and performance monitoring, and I just talked to you about the new media awareness features of Medianet. Okay, so this next section, I will be introducing you. I will be showing you working configuration examples on how media awareness features can be integrated with some of the existing iOS features. Okay. So in the next section, I'm breaking this section down into 3 different examples. Okay, and the idea of simplifying my QoS deployment and what some of the strategies I can use, I'm going to introduce how media awareness features can work with NBAR, and how NBAR can produce flow metadata information, and I'm going to move into talking about how we can actually extend our QoS trust boundaries for VoIP scenarios where PCs hang behind the IP phone. And then finally, I want to show you some working configs on how we can actually measure performance per flow using the actual metadata attributes that I just talked about. Okay. All right. So remember how I talked about flow metadata? One of the components has to be a producer. Well, the MSI is one component that can produce metadata flow information. The media services proxy is another option where I can actually use to produce flow metadata attributes. There's a third option that I'm actually introducing here, as well as its related configuration, is that NBAR can now actually produce metadata attributes in the network, right? So remember NBAR, when I was talking about this earlier, we had to turn on NBAR at every single hop, right? And sometimes that may not be feasible, okay? Because sometimes I may not want to turn on NBAR at my core, right? It just doesn't make any sense. But what if I could turn on NBAR at the edge or somewhere on the network, right? And then when NBAR learns the attributes or the specifics of a particular IP flow, NBAR can share that information with its downstream neighbors. Right? Wouldn't that be nice? And actually, NBAR 2, with the introduction of NBAR 2, there's actually integration between flow metadata with NBAR 2 now. Okay, and here I'm showing you its related configuration and how to accomplish that. Referencing the CPL configuration methodology, I had to turn on NBAR on my interface, gig02. Right? NBAR is discovering my packet flows. It's discovering the flows and its related applications. Okay. I turned on flow metadata, right, at the global configuration level, and I've also turned on metadata flow transmit. And what this does is it allows metadata to actually allows this router to originate a metadata signaling message into the network. Okay, and that's what this command does. I'm building a class map that says match all telepresence. This could have been, match all Eric, but essentially this is the name of my traffic class. Match application telepresence media. Application telepresence media. This is a specific metadata attribute that is aligned with what NBAR is pre-programmed to know. Okay, so with match application telepresence media, what this is actually buying me is that it's configuring the traffic class to trigger a metadata signaling message whenever telepresence media attributes are seen for a particular flow. Okay, and then to actually apply this to make this to actually turn it on to make it go live per se. I'm applying this traffic class against a policy map, in which then in turn I'm applying this policy map against with a service policy on my specific interface. So what's happening now is, as my telepresence session flows from point A to point B, NBAR learns its attributes, right? It does deep packet inspection magic. It's in the backend, it's integrated with flow metadata, where now flow metadata will actually announce what it's learned to the rest of the network. Okay, so let's look at the output here. Right, this is essentially my downstream neighbor from this particular device. Right, let's see what this device has learned. Right, so let me flip to the next slide. On this device, I'm looking into the metadata flow database. This is telling me the Five-Tuple information for my telepresence session. And hey, look, it's saying that it learned the telepresence media attribute in this database, right? And then if I have a QoS policy defined, this database entry is now referencing that, hey, QoS is actually using this entry. All right? And how do I use this? How do I apply this? Let's say in my network environment, my WAN service provider cloud here, they're retagging my DSCP values, right? Like I own these devices here. This is part of my administrative domain, and I own these devices here. Okay, I don't own what's in the cloud because this is essentially my service provider's territory, right? But as I send telepresence packets into the cloud, they may be retagging my values, right? They may be breaking my enterprise QoS policy. I need a way to normalize this as packets come back into my network, right? So with flow metadata, I now actually have the ability, a simple way of actually normalizing what QoS should be for my telepresence media traffic, right? Here I'm showing you show run outputs from the CPL, the CPL configuration on both of these routers. Right, and here in my WAN cloud, I'm remarking traffic just for the sake of demonstration purposes. As packet enters the WAN cloud, it gets retagged, and as the packet is received on this router here, this specific traffic class gets matched, right? Application media gets matched, and then NBAR media, the traffic class NBAR media gets to reset the DCP value back to CS4, right? And then this next slide essentially just to show output that verifies that specific policy map. Okay, here again, this is a live flow that's being sent from point A to point B. On this particular router here, I'm actually showing you some of these stats from the policy map. Right, that's actually renormalizing what the DSCP value is as the packets come into this interface. Okay. All right, so that's one way of using flow metadata, right? The ability to use NBAR to generate full metadata attributes in the network, and then being able to leverage that database, the metadata table database, to normalize our enterprise QoS, right? As if say a third-party entity is retagging our DCP values, right? All right. So next, let's talk about extending the QoS trust boundary. Okay, let's do a quick time check. All right, so I have a few more slides, so I should be okay. So, extending the QoS trust boundary, right? What I'm showing you here is a common Cisco Unified Communications deployment, the deployment model, right? Where I have where I have an IP phone, and when the IP phone sends voice traffic into the network, it sits in its own phone VLAN, voice VLAN. And on the switch, on the port that's attached to the behind the phone, I attach my PC to that. And the PC that's attached behind the phone, that sits on the data VLAN, right? And this was done by design. And the idea was I want to separate the broadcast domains, just so that in case my PC gets hit with a virus or worm or whatnot, it doesn't impact my voice traffic, right? But inherently, I want to only apply QoS services for my phone and not necessarily for my PC, right? But things have changed, and with this type of deployment, it introduces a problem where, say, what if I am running a legitimate application on my PC, and what if I want to give this application higher priority, right? How do I do this? Well, in the past, there wasn't a way for me to do this, right, without building complex ACLs and then referencing the ACLs in the class maps. But now with flow metadata, I can now actually build a simple CPL configuration at the edge here, where QoS is actually needed for my Jabber client that sits on my PC on the data VLAN. I can now extend the QoS trust boundary to the actual application itself, right? So all other traffic, like say, my traffic going out to YouTube or my traffic going out to Gmail, that still gets sent to the scavenger queue, right? But if I have a WebEx client that gets launched, if I have a Jabber client that gets launched and Jabber tells the network, hey, heads up, I have a Jabber session coming at you, and here's the Five-Tuple information. If that information gets built, if that information actually is learned by the network, then the appropriate QoS services can then, be definitely applied for that particular type of traffic, right? All right, so let's look at the configuration. So the configuration for extending my QoS trust boundary is essentially pretty similar to the previous examples that I showed you. Here on my router, I'm only applying a QoS policy here for traffic, right? Because the idea is, I want to manage my bandwidth with my provider. And essentially, I have a CPL configuration for QoS defined, right? I'm matching the Cisco phone attribute, right? And this attribute, again, this was actually announced and learned from the metadata flow signaling message, right? I have a policy defined for it. I'm marking everything EF, and and EF traffic, by default, I'm assigning it into the priority queue, right? And then, of course, the policy gets applied to the interface for all outbound traffic. But if I look, again, coming back, apologies, my show output's a little bit skewed here. But looking back again in the database, I just want to come back to this specific entry down here, right, on the bottom left side of the output. The flow metadata table database is actually smart enough to know that, hey, a QoS policy is using this specific entry, right? And then in the next slide, in the next example, there's another entry here that will tell me a different application or a different consumer is actually using this specific piece of information. Okay. All right, so I just talked about extending the QoS trust boundary in VoIP type environments. So I'm going to move into talking about monitoring traffic flows for performance by specific attributes. All right, here I'm sharing with you a screenshot of a Wireshark capture for my WebEx session. Okay, And very quickly, there's a few things I just want to point out here. At this WebEx session, it's been encrypted with TLS, right, version 1. And I can only tell that this is the IP address of my PC that started the telepresence session. And then if I do a name lookup or resolve, this somehow maps back to a WebEx server somewhere on the internet. Okay. How do we know that this is a WebEx session? Just from looking at this output, you can't tell. Okay. We only know this because I just told you what I did, right? And again, so coming back to the example where I want to apply a QoS policy or something, I want to do something, I want to apply a QoS policy for traffic that's been encrypted. And I want to apply, and I need a way to differentiate that, right? And with encryption, I can't tell the difference, right? So now with flow metadata, you can, right? And one of the other consumers of metadata flow, and I talked about this earlier, is performance monitor, right? So using the same concept, now in this example, I'm not going to show a QoS example. I'm going to show a performance monitoring example where I want to monitor what WebEx performance is like as WebEx traffic goes through, as the WebEx traffic is passed through my network, right? Again, I'm only picking on WebEx is because I have a WebEx client available and then it was supporting MSI. Right? I could have easily done this to show Jabber, okay? But I'm only picking on WebEx at the time of building this out, WebEx was the most easily accessible to me to share my configuration, okay? So my performance monitoring output. I talked about this very briefly earlier. I'm leveraging the NetFlow configuration methodology, right? I'm defining a flow record, specifically performance monitoring type. I'm defining the 5-tuple information that I want to match against for my particular WebEx session. And I want to collect the application names and other attributes as associated to the specific 5-tuple, right? And then finally, from a metric calculation perspective, I only care about round trip timers, right? And this, as I'm assuming WebEx, as WebEx is actually being sent via TCP, right? So if I apply this performance monitoring policy in a CPL Cisco policy language for perfmon, I apply it against incoming and outbound traffic. Right? Again, the class maps and the policy maps, nothing's changed much there, except again the policy map. I'm specifying the perfmon type, and I'm referencing the flow monitor I'm referencing the flow record that I predefined in the previous slide. Right? So I have a live WebEx session up. I type this command: show performance monitor status output, and voila. I'm seeing 5-tuple information for my WebEx session. It's still telling me that this is an encrypted session, meaning I'm not looking into the packet to determine what's in the payload because encryption is protecting that type of information. But I can quickly tell, and I only care about these attributes because in my network I can essentially build other QoS policies, or in this specific example, I want to measure what performance is like for WebEx traffic. Right? And I'm measuring it based on the specific application ID WebEx meeting. Okay. All right. So again, if you have any questions, please let me know. I know Monica's scheduled 20 minutes or so Q&A, so I'll definitely be happy to talk to you about some of the concepts that I introduced today and how how I built out some of my configurations. Okay. All right. So the takeaway. What did I talk to you guys about today? I introduced Cisco Medianet from a high level perspective. Right. I talked about operating video on your network using Mediatrace. Right. How Mediatrace can now actually help you isolate a fault on the network from end to end. Right. I talked about performance monitor, being able to scrutinize what performance is like from a per flow basis and getting meaningful metrics from that, from each flow. And I introduced to you media awareness. Right? I talked to you about, I introduced some of the existing problems of maintaining and managing an enterprise QoS policy. And I talked about how media awareness features can actually help us simplify that process. Right? Without changing our QoS policy or without changing our business policy, let's make it so that our configuration can adapt to just make our configuration so that it can adapt to what our rules are, right? And I showed you how we can do that with NBAR and metadata flow, right? So the takeaway, the core message of today's session is that Cisco Medianet enhances how you can operate your network to support media traffic. Okay, and I know this media awareness, like I threw a lot of information out at you today. If you have any other questions after this session, say next week, say you'll be planning on design or new questions come up, feel free to post your questions here on Cisco support forums, specifically the Medianet community. I proactively monitor this communities along with some of the panelists. And there's also other Cisco Medianet experts that's actually proactively monitoring this forum. Okay, so again, if you have any other questions, feel free to reach out to us, and definitely we'll help you out if you have any other concerns. Okay. So with that, I want to close with the final polling question. All right. I asked you earlier, the first question was like, I'm trying to get an idea of the audience that I'm speaking with today. And the second question is like, I'm just curious if from the audience members, I'm just curious if there's a global QoS policy deployed in your enterprise. And now I'm just curious to know how complicated is that policy, right? From scale 1 to 5, how complicated is your organization's global QoS policy? 1 being the least, and 5 being the most, very complicated. Again, I'm trying to get an idea of what you have today, and hopefully what I shared with you on media awareness today can actually help simplify what you have today. Okay. So thank you. Now, and Dan, I'll pass the mic back to you.
Okay, thanks, Eric. Let's get to our fun question today. What do Cisco Medianet, New York Yankees, and the Dallas Cowboys all have in common? That would be the digital media player 4310, also part of Medianet. It's a digital signage device that lets businesses display and distribute content. Digital signage has been a key part of Cisco's efforts in the sports arena business, where the company has played a role in such facilities as the new Yankee Stadium and the football stadiums for the New York Giants, New York Jets, and the Dallas Cowboys. Okay, now let's get over to the Q&A portion of today's event. Remember, you can still submit a question at any time. We have a limited amount of time, so we're going to get to as many as we can today. Also, don't forget to fill out the survey that will pop once you do close the window. Everyone who does fill out the evaluation will be entered to win a $20 US dollar gift certificate. So please do that. Also, if you have additional questions, Eric will be answering questions in the Cisco Support Community Forum from August 21st to August 31st. Okay, let's get to our first audience question. Just sort of a two-part question. They want to know what version of iOS was Medianet introduced, and also is it only in iOS that you need to run Medianet, or is there an actual specific product that's connected to it as well?
So to answer that question, I have to look up the specific minimum iOS versions, but the answer to that question is you need a combination of both. Medianet will only run on specific hardware at this point in time, and on each specific hardware platform, there is a minimum required software licensing feature to activate some of these features that I talked about today. Okay, so I hopefully the slide deck that I've included, it can actually get downloaded from members of the audience. Hopefully the slides that I created today can be shared with the members of the audience, because I've included the data sheets on the first two slides that actually point you to a URL where you can actually get a data sheet that shows you more of a comprehensive list of what's actually being supported by Medianet today.
Okay, sounds good. Let's get to our next question. Can you leave Mediatrace responder on across the network without CPU proc impact and simply trigger its use by doing a Mediatrace initiation?
So I think so I can understand the context. I want to just dig a little bit deeper into that question. I know I didn't cover a lot of details from Mediatrace, but this question often comes up, and it's usually around performance with Mediatrace. So the quick and dirty answer to the question is no. Mediatrace responder running as a service sitting in the background, if it's not being used, it doesn't really impact system CPU performance. Okay. But with that being said, Mediatrace, what I showed you today was just a simple Mediatrace responder configuration. What we would recommend is when you turn on Mediatrace responder, be sure to define an upper limit on the total number of sessions that the Mediatrace responder can reply against, right? And the idea is we like building safety mechanisms for us, so in case if I turn on any new features onto a production environment, I don't want this new feature to expose my network to any sort of risk. So the long answer is no, CPU utilization, memory utilization will not get impacted. But again, it's recommended to apply an upper limit on the total number of Mediatrace sessions that the responder and the initiator can start and reply against. All right.
Okay. Get to our next question. What authentication is available for this feature?
I need a little bit more context.
Yes, I don't know. That's all we have for that question. Okay, it might be a little bit too broad. So that is your question. If you want to provide a little bit more context and resubmit your question, you can do that now. But let's move on to another one. Can you use this for other apps besides telepresence or voice calls?
Yes. The question is, can I apply Mediatrace or Performance Monitor to Citrix traffic or VMware traffic? And the quick and dirty answer is yes, definitely you can. Because again, remember guys, I'm using the class maps to define the traffic classes that I care about, and once I know what I care about, I can then apply the different performance monitoring or Mediatrace type service against that. Okay. Good question.
Okay. What ports or protocols are required to be enabled on the Mediatrace routers?
So Mediatrace again uses RSVP as a transport mechanism. So just be sure that you have IP protocol 46 allowed. Okay. So again, RSVP uses IP protocol 46. If IP protocol 46 gets denied anywhere, the Mediatrace signaling message will stop at the point where it was actually filtered. Okay, and you only get a Mediatrace report up to that device hop that dropped the message.
Okay. There's another question. What are the limitations? For example, the number of flows. At what point will what are the limitations of the number of flows that it can handle? And at what point is there a point where the amount of data would be too much for the router? So the question is asking about stress testing Mediatrace. Unfortunately, in this slide deck, I don't have those numbers. I have to look this question up. I have to look up the numbers for this. I don't know the facts from the top of my head. Mike, I don't know if you're there, but I don't know if you have that data available. But let me take that as a follow-up.
You'll have to repeat. I was answering another question.
Okay. How can the devices distinguish between the different flows for the different applications?
How can the devices distinguish the different flows for the different applications? So I'm assuming the context of the question was popped up around when I was talking about Cisco Media Services interface. Okay, so please stop me if my context is off base. So essentially MSI, it's an API that application developers can actually leverage, right? So if I'm a WebEx application developer and I know that MSI is there, then it's up to me to leverage what MSI can offer and announce into the network. So for the time being, MSI is not open to the developer community yet. So MSI is actually being applied for specific Cisco endpoints at this point in time.
Okay. Well, I think we have a rephrase of one of our earlier questions here. What authentication is required to be able to use the Mediatrace feature? More specifically, can an unauthorized user glean network information from the network devices by using Mediatrace?
That's a
how do you
really
how do you restrict access, basically?
So that's a really good question. How do I prevent Mediatrace? How do I prevent any sort of users from just kicking off Mediatrace, right? So I think there's multiple prongs to answer that question. So I'm gonna take a first stab at this. So if I don't want my first tier help desk guys to pretty much kick off Mediatrace sessions at will, I guess we can always use AAA authorizations to define the user level of access. So again, Mediatrace is just like any other iOS command, right? If I restrict users from being able to enter that and they're not authorized to kick off Mediatrace, then that's one way of preventing them or denying them. Dan, in my Q&A window here, I actually got one question. I think it's a pretty good question, and so if I can share that with the audience.
Okay, go for it.
The question I got is, will Mediatrace work if there is a non-Mediatrace capable device in the past? Mike, I don't know if you answered this question already, but that's a really good question that we get often. So you don't have to have Medianet features installed everywhere on your network for Mediatrace to work. So in my example, like I showed you an end-to-end solution where I turn on Mediatrace everywhere, but let's just say two of those devices in the past does not support Mediatrace. What happens there is that those routers will essentially just forward my RSVP message like any other type of IP packet, right? It's just that those routers that don't support Mediatrace, it won't be able to interpret the Mediatrace RSVP message, right? So it'll just simply pass that message along. We'll just route that message like any other data packet. So from the console perspective, when I get a final printout of what performance is like for every single hop, when it gets to the point where the router did not understand Mediatrace, I essentially get an IP address. It's like a quick blip that tells me, hey, my media path took these network device hops to get from point A to point B. And oh, hey, by the way, that one hop that didn't support Mediatrace, I essentially just get an IP address there. And the way that IP address was detected, it simply used traceroute to detect that specific hop in the network. So that's a really good question.
Okay, let's try another question here. This one's about NBAR. By default, NBAR version 1 is configured with a port map list. What is the purpose of the port map if NBAR is doing a full 7-layer payload inspection to determine traffic type?
So the question is, what is the purpose of configuring NBAR 1 using the port map list if I can just use the protocol? If I can just use the protocol discovery method? That's a really good question. Without understanding the specific scenario and deployment, the specific deployment case study, I'm not sure how to answer that question. So apologies ahead of time.
Okay, that might be a good one to come back to the Cisco support community post-event.
Right.
Is Medianet available on the smaller SOHO routers?
So the SOHO routers I know that I'm running out of my house that Cisco gave me is we're running Medianet Mediatrace and Performance Monitor on the 891 series router. That's the only platform that I'm familiar with. But again, please reference the data sheet. That's actually more of a comprehensive list on what's being supported out there for Medianet.
Okay. Another question. What are the core Layer 2 and Layer 3 devices between the 4K and the ISR G2s?
So the question is probably, I'm taking a stab in the dark here, is that in my logical reference topology, what are the core connecting devices that's tying my access layers with my edge routers? In my lab, to build out this slide, I'm actually running a pair of 6500 catalyst switches.
Okay. Get to another question here. When should I enable metadata flow globally versus per interface?
So the question is, what's the difference between turning on metadata flow for all interfaces or just simply for a single interface? So one way to restrict how the metadata flow signaling messaging gets propagated through the network is essentially just by turning on metadata flow for a specific interface. So say, I'm a router and I have 3 interfaces. I only wanted to route out route the media. Let me get a sip of water really quick. In my example, I have a router, 3 interfaces, and I only want to restrict metadata flow to be routed out 2 interfaces. I essentially just define metadata flow on those 2 specific interfaces and not globally. So it's more of a policy in how I want to control the metadata signaling message. That's when I would actually alternate to different use cases.
Okay, I think we have time for one more question here. How can we find out what applications are supported via metadata?
So currently, I know from Cisco's perspective, what we've been testing with is, from a software perspective, Jabber 9.0 is supported. The WebEx client is supported. Some of the telepresence endpoints are running the newer firmware that's actually supporting metadata. For a full list, up-to-date list, again, you have to please reference the data sheet. And at some point, I'm not sure when they're going to announce this, but they're talking about announcing MSI to the developer community. And at that point, pretty much, when we announce it in the wild, it's up to all the application vendors to be able to leverage that type of service.
Eric, I just put the NBAR 2 list in the chat for that question.
Let's see. Yep, Mike, I'm having problems with WebEx. I can't seem to find that URL for that NBAR question.
Okay, that's something that everyone can download post-event. We'll have the list of all the Q&A, and you guys can also post that question in the Cisco support community forum around this webcast as well for additional follow-ups.
Yep.
Okay, that's about all the time we have for the Q&A portion. Just go through a couple of quick housekeeping slides for some upcoming webinars that we have. Our next Expert Series webcast will be in Portuguese. The topic will be basic tools for troubleshooting Cisco adaptive security appliances. That'll be on Tuesday, August 28th. Following that, our next English Series webcast will be covering cable modem termination systems, architecture, configuration, and troubleshooting. That'll be on Wednesday, September 12th. And we have a few current Ask the Expert events going on within the Cisco support community right now. Setting up and troubleshooting WCCP on iOS, understanding and troubleshooting ACE load balancers, preparing Cisco Unified Communications Manager 8.x to support Cisco Jabber for the Android and iPhone. You can read more about all of these events within the Cisco support community. We have a few other events starting next week. RF Gateway 1, installation, operation, and troubleshooting, as well as intrusion prevention systems. We do invite you to collaborate within the Cisco support community and their social media channels. You can see them all listed here. You can also reach all of them by just visiting the Cisco Support Forums website at supportforums.cisco.com. And as a global event, we do participate in many different languages, Spanish, Portuguese, Japanese, Polish, or Russian. So please do check back as we have events in all languages. I want to thank Eric for his time today, and thank you everyone for joining. Please do check back for our next event, and we hope to see you soon. Have a great day.